right, this should look familiar to us. Let's count these sig figs and these measurements. A, every digit that is not a 0 is significant. That's 3. B, 40,506 millimeters. Now, who would ever write? You're never going to see that. They're just going to write things in meters or some other unit. But for the sake of the lesson, let's do it. The zeros, it's all about the zeros. All right, zeros in between non-zeros are part of the measurement. That should be very reasonable to anybody. You measure anything, and this is a distance thing. So you measure an object, and it turns out to be that number there. Of course, that 0 is part of the measurement. Of course, that is part of the measurement. So there should be 5 sig figs. All 5 of those digits are part of that measured quantity. C. Now, why would anybody write a 0 at the end of a number and to the right of a decimal? They would only write that if they went out of the way to measure that precision, to measure that degree of exactness. All right, so this is 4 sig figs. And we learn when you write numbers this way, and this notation is called scientific notation, every digit in the coefficient is significant. All right, and just one of the rules we ask you to remember is trailing zeros at the end of a decimal. Those trailing zeros are significant. So that's 4. On a D, meter sticks. This is kind of tricky because meter sticks are used to make measurements, but this time you're just counting meter sticks. That's a little, can be a little, I can see how that can trick some people. All right, but you're not, this is not measuring, this is not a unit of measurement. That's an instrument to make measurements. So you're just counting sticks. You might as well just set sticks. All right, so this is unlimited. When you're counting objects, that number 22 has unlimited precision. 22.000000. You can say that for the rest of your life, and it'll still be more precise than that. All right, it's perfectly 22 meter sticks. All right, we're not talking about broken meter sticks. All right, E. Leading zeros are never significant. All right, but we need them to hold the places of the part that is actually measured. All right, so there's our measurement value, digits that are part of the measurement, significant digits. All right, so that has 4 sig figs. All right, again, the zeros in between non-zeros are significant, and trailing zeros at the right of a decimal are significant. Nobody would write that 0 after the 8 if it wasn't measured. If that wasn't measured, they would just simply not write it. All right, so it was measured. That has 4 sig figs. F has 2 significant figures without any other information. Now, if you see a dot there or maybe a bar there, then yeah. All right, and we would just write it in scientific notation. If we wanted to tell somebody that had a 5 sig figs, we would write 9.8000 times 10 to the 1, 2, 3, 4. All right, we would just write it like that. It would be just much more convenient and clear. All right, but it's not written like that. So you just got to follow our rules. All right, and say these are the only measured part. There's your certain digit, there's your estimated digit, and these that we have no idea what they are, so we can't say they're significant. So in other words, zeros that are at the end of a number, but on the left side, there are no decimals, you can say, they are not significant. Now maybe they are, but the only person that knows is whoever measured it, right? But for the fairness of everybody else, we have to make these rules, and so that's 2. Only the 9 and the 8.